ಸಚಿನ್ ಹೇಗಿದೆಯಾ? ಹುಷಾರಾಗಿದೆಯಾ? ಸಚಿನ್, ಆಡಿಯೋ ಆಡಿಯೋ ಕನೆಕ್ಟ್ ಆಗಿಲ್ಲ. ಓಕೆ, ಫೈನ್. ಬೇರೆ ಅಡ್ಮಿಟ್ ಮಾಡಿದ್ದೀನಿ. ಎಸ್ ಗುಡ್ ಮಾರ್ನಿಂಗ್.
Good morning, Digant.
Hello, good morning.
Hey, good morning. How are you, Sachin?
I'm good. I'm fine. Thank you.
Great. Adanya, good morning.
Good morning, sir.
Okay, so let us get started. Okay, let us just take a look at what we learned yesterday and proceed from there. Okay, day before yesterday, we learned about data types, and remember these are our data types: list, tuple, dictionary, set. Set and dictionary are very good for searching, and list and tuple are similar, but tuple is different than list in terms of read only and write memory, which is tuple is read only. So remember that that's the main difference, which is also called as immutable. It's not mutable. Let me admit. And then we looked at if-else conditions yesterday, and then we also looked at loops. I'll tell you more about loops today as well, a couple of things. And yeah, and then we had this exercise. We learned about functions as well. So functions, you know the syntax of the function. If you use the keyword def, so that's the function, and you have some variable name, which is a function name, and you have arguments, and then you have return value. So these are the things that we discussed today. And also we discussed about arguments and default arguments. Okay, and yeah, lambda functions I'll teach you later. Yeah, and we learned something about scopes. So let me just give a clarification in Python and other languages. So in Python, scopes are limited to, since it's an interpreter, it doesn't know what is down below below its current execution code. So it's difficult to know its scope, like in C++ and C. For example, in C, you will have something like if condition. Let me annotate it here. So this is a code block, and even in Python, this is a code block. But you can access this particular element outside its code block in Python. Whereas in C, C++ and other, which uses which gets compiled, you cannot access this particular element here outside. So this is the main difference. So just remember that in Python, scopes are within the function. That is, in Python also you can do a function inside a function. So you can define a function inside a function. So those are called as enclosures or something like that. But idea is you can use functions inside function, define functions. So yeah, just remember this. This is one of the main difference. And let me and what else? Yeah. So those are the things. So let me get back to the editor and let us learn something new about loops. Okay. I have installed something called as Jupyter Notebook. It is good for teaching, and you don't have to. Usually we trigger the programs on the command line, or click on run on IDE and it triggers. In Jupyter Notebooks, there is a nice way that you can put the code snippets and you can run just that particular snippet. This is good for teaching, and also going forward we will use something called as pandas library, wherein we can work on the tabular structure of the data, and it is used in data science, so that you can see the table and you can decide what to do and you can look at the output very quickly. So that is about little bit about Jupyter Notebook. You can install it if you want, but it's not necessary as of now. You can use the usual one. So yeah, since this is good for teaching, I'll just use this, because if I start writing the code, it will take more time and it might get boring as well at some point. So yesterday we looked at for loops. So there is a range function, which is nothing but if you use range, it's like telling that generate from something which is called as initializer. Yesterday we looked at initializing. So it automatically initializes to 0 and it runs till 5, excluding 5. So 5 numbers. So range 5 gives us this. So if you just want to iterate, or if you just want to do something in loop of some n number, you can simply do this. Okay. So this is about range. One of the things that you need to just remember that. And there are two things that can be confusing for beginners. One is break and one is continue. So to break out of the loop is nothing but, for example, yesterday we had an thought exercise wherein we tried to imagine a piggy bank, and then we broke it, and then we tried to count the number of coins. So in a loop. So that is how we try to understand the loop. So in case you want to break out of that loop, for example, uh, after some coin, you say if I get 10 paisa coin, which is no more valid, I need to break out of the loop and see why this has come or something like that. So you just break out of the loop, that complete execution box. So this is how you come out of the loop. So it's just break out of the loop. So you can see that we are not doing anything below this particular break. So break just breaks out of the loop. Okay. So there is also a keyword called as continue. So continue is nothing but it's like if you the same example, if you encounter 10 paisa coin, while you are counting, okay, skip that 10 paisa coin counting, or counting is nothing but the instruction that you have later, like I is equal to I plus that particular coin, and just forget that particular iteration, go to next coin. So that is the continue one. So if you remember this example, continue and break is easy to understand. So this is how the continue works. You can see that we have generated 10 numbers, and if it is even number, so if you use modulo operations, it gives us the reminders. So any number divided by 2, if it gives no remainder, which is an even number. So that is the logic here. This is to check even number. And if it is even number, continue, which means skipping that part of execution. It is not coming out of the loop completely. So skip that execution and print, or do the execution, rest of the execution in the for loop. So this is these are the two things that you need to remember in loops. And yesterday we also looked at there are the inbuilt data types, which are list, tuple, and then dictionary, um, and sets. You can simply use like for x in that particular data type, and then you can simply loop, because the iterations or the iterators are built into those data types already. So Python knows how to jump from one element to another element and where to stop. So that is the crux of the loop, right? Initialization, the condition for to move forward, and then condition to end. So yeah, these are the things, three main things. So I just wanted to show you how while loop is used here. And we don't use while loop much in Python, but just for your information, it's like initialize something. You can, in order to create a infinite loop, you can simply do something like this. If true, do something like this, and it keeps running for like ever. You can see that it's running always. You can even stop the execution. So on your command line, you can just press. And so in fact, so while loop uh, is like you have while and then you have some condition. So that condition you can define just like in yesterday's class. I was telling you where to um, stop, right? So if it is uh, lesser than, until it is, this condition is correct, evaluates to true, it will keep on doing this. Once it evaluates to false, it stops. So that's about while loop. So this is just for information. Yeah. Okay. So those are about loops, functions, and the scopes. Let us look at some new concept today. Yeah, we already know dir, type, and id. So yeah, let us get into like objects. So far you have learned the bare minimum skeleton that you need to write programs in Python. So basically you need data types, how, why, when to use, what to use, data types, and then you know how to control the flow of the program, which is nothing but if, else if, and then using loops, which is for loop. And this is like basic construct of any programming language. And then comes how do we transfer our ideas, like how do we think, like how do we transfer our thoughts as we think in the real world. So that is where the object oriented programming comes into picture. So as I was mentioning in previous classes, so everything is an object in Python. So for example, in this snippet wherein we have snippet, so x is initialized to 5, and we tell x that you are an integer. So compiler looks at this particular variable when it is compiling, and it allocates it this the memory that is required to store 5. So usually it is 32-bit because integers are 32 bits on a 32-bit machine. So it's like you are allocating or you are reserving that many bits, 32 bits on the RAM. So that is something which you need to remember. But when you talk of objects, if you look at Python example here, x is equal to 5, we are not mentioning anything here. So Python interpreter dynamically allocates and knows, okay, this is an integer, and then it allocates that many bytes. So it is not 32-bit that it allocates, but something more. Why something more is because x is also an object. So if you look at x is equal to 5, and we saw that what is the type of x? It says that it is class of integer, which means it is an object. So we also looked at a function called as dir, and we looked into function. So there should be some way to tie these functions which are here, these functions, plus that particular variable, right? X is equal to 5, that value. So this value plus these functions which are built in together to an to a data type is an object. So in real world, we see the pen, everything around us is an object. So if you start looking at it programmatically, for example, car. So if you want to write a program uh, say simulate a car, so you would be listing its function out, and then you will also listing its attributes, which are nothing but the values that it carries. For example, attributes are nothing but like tire, gear, and all these things. So, and then operations are like to do something on top of that attributes so that you control those attributes. So these are the operations. So for example, I have a highlighter here. So if I have to write or if I have to write a requirement for this, what are the attributes? So it's color, and it's say size, and it's material type. So these are all the attributes. And then what is the function? Function is like you can open the pen, you can write a function which is open, and you can also write a function called as close, and you can also write a function to write, so or mark. So these are the functions. So these functions are also in object-oriented programming called as an interface. So when you hear interface, when you are in a meeting or when you're in a technical discussion, just remember that it's a function somewhere inside the code. So we say REST interfaces, which are like REST APIs interfaces. They are nothing but an interface, a function which is written inside somewhere, which gives us the control on attributes, and then you can also operate on that. So that is about the attributes. I'll talk about user attribute later. Okay, so this is just an introduction of objects. There is a complete lesson on uh, object-oriented programming. So I'll get into that later. So today we will learn more about files and file operations because the reason that I explained about objects is to help you to think what are files and how you can think about files like an object. So let me use pen here. So that's it. So when we spoke about files, when we speak about files, so as you know that why do we need files is because we want to retain the data when we switch off the computer. So that's the basic idea of like why do we have files, and these files are stored on a magnetic disk, right? So it has its own format and things like that. So when you install a computer, you might have heard about like FAT32 and NTFS and so on. So these are file formats. So this tells us um, tells the internal operating system that how you want to store the data inside this hard disk. So that is a protocol, or it's a standardized way of storing the data. So remember that why do we use FAT and all these things, FAT32 NTFS and these things, and what does file mean and how it is different than the variables that we initialize. So these variables, as we execute the program and exit out of the program, this vanishes. So how do I store this where the data, in this case it's just the variable, into the file? And what is a file? So file is nothing but, so you have hard disk, and hard disk is connected to your laptop or computer, and then you have a RAM inside that, and then you have the CPU, right? So CPU is the one who does the operations. For example, you read some data and say you read a table and you want to sum it up. So the action of sum is done by CPU, and then loading that data and all these things. So how does this data gets loaded to the RAM, right? So how do we load it? So in fact, when I open this PPT, it's on the disk, and when I double click it, it gets loaded onto the RAM, and the CPU is executing that. So that is why you're seeing the slides and you're seeing the handwriting on the screen and things like that. So so there are a lot of processes which are running on the operating system, and this is one of them, which is multitasking, and then process is coming in and out. So when we talk about files, so this file could be, my RAM could be say 1 GB. This file could be say 5 GB. So how do we, when I open the file or when I load the file, how do I load the file so that it is impossible to load of 5 GB, right? So how do I load it into the 1 GB RAM, because I want to do some operations, is taken care by the operating system internal functions. So it just reads whatever is the memory available. Say I have say 50 KB memory, which is allocated to that process. And then out of 5 GB, I just read 50 KB. And then when I say I need to read more data from that file. So let us take a file and then write something into that. Imagine there is a file, text file, and then this is of say 1 GB. And then I load only this part. And then once I process it, I load more and things like that. So step by step, so section by section, I'm trying to do some operation. So what are those operations? So operations could be read operation, and it could be write, and it could be append. So there are only three operations, right? For example, if you write something on your notebook, so there are only three operations that you get. You can say just read a book, which is you are loading that book from the table and onto your hand. So this is like a RAM, and then you read it and you keep it back. So how do you read it is, once you open the book, say if you have read some concept, so you go to that particular concept, look at the content, and then go to that particular page number, and then we read, and then we close the file. So these are the steps that we do. So since it is natural to us, we take the book and just read it and then keep it. So if you want to think in terms like like a computer, so you would be doing steps something like So loading is happening by using the operating system already. So load is taken care, and you want to open the file. So you are opening the file, and then you are reading certain content from the book. Say reading, okay. And then you are closing it. So these are the steps that you do. So how do you do that in programming is you want to tell that I want this particular file. So what do you need? Obviously you need the file path, which is say, let me take blue. I need a file path. Let me write here, because I need to know the location, because I picked a book from the table. I know the location of that particular book. And then you also want to open the file with that file path. There is a function called as open. We open that, and what gets returned from this open is something called as file descriptor. So file descriptor is nothing but handle, or you can translate that to, for example, I open the file, and you can see when the kids read that, right? So they use the fingers, and then they're like reading uh, through the book, right? So they use their fingers and then read. So we also used to do it in school. So this finger that you use is called as cursor, or in database it's called cursor. You can also use that as like a file pointer. In C we call that as file pointer. Here we call file descriptor, because it's just a pointer in C. Here it has more functions into this. Okay, so just remember that it's just like a finger. And then you can do a lot of operations. For example, I can read from one line and then go to next line. So you can read like line by line, or you can read character by character, or you can read everything in one shot, right? That is up to the reader. Okay, read all. Okay, so these are the operations that I'm doing while reading. So how about writing? So when I open the file, I need to tell the operating system that I want a file to be in a write mode. So the reason that we do is by default, a file cannot be opened in a write mode, because there could be accidental writes on the file. And also it is costly to maintain say some some process to wait for getting it to be written. So it's costlier than reading operation. So by default, all the files are opened in read mode. And if you want to specify that I want to open it for writing, you can use, there is an argument to this particular function. You can say that there are some characters which define what mode you want to write. So you open that with write mode. Once you start opening that file for write mode, this file descriptor also has something called as write function. So we discussed that object means there is attribute and there are functions. So these are the functions that is related to that particular file descriptor, or the file operations library. So what can you write into the file? You can write, computers can understand only ones and zeros, right? So ones and zeros in the sense that it is magnetic signals in terms of hard disk. So when we read or write, you can actually, if you have a computer which has the rotating disk, so once you write something and enter, um, press enter and execute that program, you can actually listen to that rotating sound of that disk. It will start making sound, because it is writing to the magnetic disk. So now you can understand how costly it is to write. Okay, So that is the reason we do not open it in reading mode. In fact, you can also listen when you start reading the file. It rotates and then it gives the data. So that is about right. So, but in higher level languages like Python, you can write anything that we can see, for example, hello and things like that. So this will be converted into ASCII, and then that will be converted to ones and zeros, and that will be converted to magnetic signals, magnetic this one. So if we are using this sort of hard disk. So these are the internals of operating system, which we don't have to worry, but you need to have uh, a flow of thought uh, when you start opening a file and when you start writing it. So these are the things that happen. Okay, there is a magnetic disk waiting to be written, and then I open the file in certain mode, and then I write something and it goes into this. So reason that you need to have such thought patterns is because sometimes you could end up in problems like it won't allow you to write. It will say it will just exit out of the writing section of the code. It can give you various errors, and you should be able to understand this. So if you have this thought, you can translate or you can debug those errors. Okay, so these are the operations on the file. So anything that we do or anything that we do while accessing the disk are all file operations. In fact, in Linux, or everything that is there on the Linux, like peripheral devices, network devices, ports, all these are considered as files because the files have a certain location. You can have a network location, for example, NAC card as a location, and then you can also, in fact, the terminal that we open, that is also a file for Linux. You can if you see list of open files, so there is a command to look at. So it will show that as tty, some slash tty slash pts, something like that. So yeah, so that is about files. Files are something which are very close to operating system, and we operate on those files using these functions. So let us look at the whatever we have learned. We will try to translate that onto the code and see what how it looks. So any questions here? I'm going to erase this in terms of files. Okay, I'll clear my drawings. Let me just create a raw file. So we understood that file, I'll initialize some file path. File path is equal to, let me read this particular file. Okay, so I am going to copy the path. So you can right click and copy, and I'm going to paste it here. So since these paths need to be in string format, I'm going to enclose it using these quotes, double quotes. You can try that, and then I'm going to open this file. So file path. So in fact, if you are using an IDE, which is integrated development environment, so when you type open, it will automatically give you the documentation of this particular function. So yeah, you can see that file, what are the arguments and things like that, but you'll get used to that. So for now, just remember that we are using this function, and since we are using this function, so, if we simply open, we won't have any handle to read or write, right? So we need to have some sort of handle, which that handle is nothing but the file descriptor that we spoke about. So file descriptor, I'll just name it as FD. This is just a convention. It is, you can name it as anything anything you want, and then I can do something like FD dot. So you can see that it is already giving me suggestions to use the function. So these are the several functions which you have built into this. So I'll just take read and see what happens here. Okay, and I will store. I'll just print it. Let's see if it's printed. I'll put this here. So let me show you what is the content of add.py. So these are the contents of add.py. So it has printed the same contents here. Okay. So you can see that I used read and read everything. So it knows the structure of the file, which is beginning of the file and end of the file. And let me try to read it line by line. You can in fact use read lines. You can there are several functions you can keep trying inside that. For example, read line, it just read the first line. So if you want to read all the lines in one shot, you can do it like this. So again, it has given the output is a list with something like this. I'll explain you what is this. Let me clear this. Let me take a moment to explain this. How is it different from the read that we saw in the beginning? Okay. So you can. So when we did read, we saw the file just as in add.py, but when we did read lines, it looks something like this. So let us try to understand or decode it. So it returns a list. So this is a list. Okay. And you can see that there is /n here, \n for every line. Okay. So where is this coming from is these are called as in computer language. I think people are familiar with already, familiar with this already, new line. And there are several characters which we do not see with our bare eyes. For example, new line, which is when you enter or when you press enter key on your keyboard on notepad, so you open a new line, right? So that is nothing but new line. So and then reads line by line, and it returns a list with each of this lines in as elements in the list. For example, this is 0th element, and there is a comma here, which tells us this is a new element. This is another element, first element, and things so on. So when you want to take the output from the file, for example, if you are reading the numbers and you want to take that particular list and just sum of all the numbers from that file or do some sort of operations, you can store that into a file and then you can add those numbers easily because we know how to loop through the numbers, and then you can do it. So this is how you read the file. So by default, as I was explaining, it opens in read mode. So what do you need to do when if you want to write something? So let me try to showcase how the write works. Write. I'll just write a comment and see what happens. So write test. We'll get a bit of this annotation. Clear. Yes. Clear this. So we're trying to write something to this particular file. Let us see what happens. You can see that the line number 5, which we are trying to write, it has printed 6. So where is the 6 coming is, so write returns number of characters or number of bytes written to a file. So there are like 5 elements here for our bare eyes, and plus there is a space. So including all of this, it's 6 bytes or 6 characters. So 1 character is equal to 1 byte because characters take 1 byte on the memory. So, okay, so that is about write, but there is also a catch here. So let us look at what is happening in add. Let me close this. So you can look at this add file. So now the previous content has gotten erased. So there is nothing in the file, and only this particular thing is there. So why is this happening is when you start opening the file for write, so we are tuned to think in terms of like usual human interactions, right? Say for example, if a teacher says, okay, write this assignment down, we will just open the file and then we don't start writing it from the beginning of the file because there are already some notes written onto that, and then go to a page where it is empty and start taking the notes, like taking that assignment, right? So what we are actually doing is we are appending that file um, in terms of computer. But if you want to specifically say that you are appending the file, please, teacher has to say, please open your notebook and append to this append this assignment to your textbook, right? So that's like a long statement. So we say that, okay, write down the uh, assignment, right? So we already know that writing down means opening the file and then appending that into the file. So, but in computers, it's not like that. We need to be very specific. So when I opened it for writing, it opened the file and the file descriptor was pointing to the beginning location of the um, file, and it just started writing. So how do I append and retain the content and write? So that is called as append mode. For example, I will open this in append mode and let me write more text, test 1, and see what happens. I'll execute. So you can see that it says I have written these many bytes, 8 bytes. Okay, if you count from hash till 1, it will be. So let us look at the file here. So you can see that I have appended the file here. So you can also see that I have not, or the computer has not appended to the next line. So the next line, the idea of the next line from human thinking to computer thinking is totally different. So when somebody says, okay, write down the assignment, you write it down and then instructions, you automatically try to format it. That is because you can later read it um, nicely, or you know how the information is needs to be formatted. So this is, if you compare your notes with your friend's notes, probably he or she is doing in a different way, but his format is different and your format is different. That information is already, we have learnt it automatically and we're trying to do it, but in computer it doesn't know any context. So when you write something to file, it opens the file, and when I open in append mode, it goes to the end of the file, the last character, which is nothing but test here. So here, this particular soon after T in this line. And then the pointer is pointing to that, and it just dumps all the characters which I am trying to write. So these characters. So that is what append means. So how do I append a new line? So obviously you can simply write something like, now we know what /n means. What is a new line means. You can also write something like this, test. So I'm trying to append the characters with just this character added. And you can look at this. So I have now it has added in the new line. So you can see that the new line is not since also it is visible, but we take it for granted. You say that okay, new line is here. Okay, we don't read test1/n and then you start reading from here. So that is the difference between our human thinking and the computer, how the computer works. So this is about append and appending new line and things like that. Okay, so we learned how do we open the file in read mode, how do you open the file in write mode and write, and then what is the catch while writing the file. If you open it in read mode, it is like you are overwriting the file. So that is why we have something called as append, and append goes when you open the file in append mode, the file descriptor goes and goes to the end of the file and start writing from there. And also you can, if you want to write new lines, so you need to append your files in such a way that there are new lines. Okay? So any questions in files in terms of concept or in terms of the programs?
No.
Okay. Okay, great. So let me okay. Would you like to try exercise now, or you want to take it home? Anything is fine for me, because yeah, this session I just wanted to teach about objects and then file operations, because this is important, because file operation is like if you start working on any project, there will be some place where you read the file. So most of the time. Yeah, you can do this exercise at your in your home, and yeah, let me.
Yeah, I just had one question though there. So the file path, if it's not in C, we just have to use the other drive wherever we have saved.
Yeah, it will tell you that it doesn't exist. Let me simulate that. So this particular file doesn't exist. Okay, so let me. Yeah, it is in append mode. So you can see that it has created a new file. So in append mode and read mode, or sorry, in append mode and write mode, it will automatically create the file. Okay, let me just put it into read mode and give some file which doesn't exist. Add 3 doesn't exist. You're trying to read a file and it says file not found error. So while we are doing projects, I'll tell you how to like organize these files in a separate file and things like that. But this is just about operations on file. Just remember that you're operating on a magnetic disk or disk, which is a peripheral disk. So that is important to remember here. So sometimes what happens is if you are trying to do performance testing, which involves files on the hard disk, and you are trying to set some benchmark. Say if the character processing is some X during one test, and you're trying to read file and do some other test, and it takes a lot of time. So sometimes we forget that okay, we are reading from the file, and it is probably 8 or 10 times. It takes more effort for CPU to go to that location and fetch, because there are several things that happens underneath the operating system. So file, you can think like you are weightlifting. So it is weightlifting for CPU. Okay.
So every every read or write has to start with the print operation.
No, no. This it doesn't have to print at all. Like you don't have to
Print is just to see the output.
yeah, because we
Okay, got
need
it.
to validate, right? So
Okay, yeah.
in fact, all the production code that we put on the production servers, we remove all the prints. We just use there is a library called as logging, and we use that particular module so that all the things that we want to see later, we can fetch that file and look at the logs. Yeah, so there are Git hooks, which are Git is nothing but the code controlling software, which is used widely. And you can also tell the Git that do not allow somebody to check in with print statements. So print is just for our learning and validating. Okay, what else for today? Okay, so let me also just show you how do you, now we have learned about files. Now I'll show you something about how do you write your own data types. So that is just a basic introduction of object-oriented programming. And sometimes we are tuned to think that object-oriented concept is actually an advanced concept. In fact, it is not an advanced concept. It is natural to humans, for example, because our thought process is always in terms of objects. So I'll show you how to create our own objects. For example, class. Let me write, say, this marker, and I can say, okay. So every class or every object has, when we try to initialize it, there is something called as constructor. In why do we need constructor? Is because now if you use, say, int is equal to x, here, sorry, x is equal to 2. So interpreter knows that, okay, this is a type of integer, and then I need to allocate some memory onto the onto that for this particular variable on the RAM. So, but how does it know that we need to, like, I need to put 2 into that that space of memory, right? So that is called as initialization or construction. So construction in terms of object-oriented programming is nothing but this. So we have RAM, and when I say x is equal to 2, so there is some class who has written the class implementation for this particular integer. So there is int, and then there is some sort of construction happening. So that construction function is put into something called as init in Python. We will learn more about init, but I'll just show you. So when you say 2, so it sort of first allocates it and writes 2 on top of it, like, yeah, the bits of this 2, like this. It will just write ones and zeros into that RAM location. So that is about initialization. So any object has got, in fact, it has got 3 steps. One is creation. Creation is nothing but asking for the memory. Second step is to initialize that memory, to write the data into that particular memory. And when it exits out of the context, there is a destruction, because the reason that we want to destroy that object is because we want to free this memory space for some other operations, right? So because RAM is limited. So these 3 operations. So let us look at, say, init. Init is the function. So in Python, if you start writing functions in IDE, it will already tell you, like, what needs to be used. I will just write some, I'll explain you what does this mean. Marker M is equal to mark. So let me try to execute this, and if it gives an error, let's try to understand why it is like that, and so that we understand the construction of the class. So you can see that we got an error, type error, and we're trying to, in line number 5, what we're doing is we're just trying to, just like we did x is equal to 1, we're trying to do m is equal to, instead of 1, we're trying to do marker this braces. So we are trying to create an object. While trying to create an object, meaning we are trying to allocate the memory on the RAM, and then we're trying to initialize it. So when we do this, so there are some internal functions gets called, but for us, like for the Python users, programmers, so this is our important function. So it asks for the memory from the operating system. It says that, okay, allocate this much memory and give me the pointer, and it has already given, and then I write something into that. So I can say this is hello marker. And when I execute it, it works here. So reason that it gave this particular error is because it is expecting some arguments here. So in Python, it is slightly different from C++ if you are coming from C++ or Java. So this is not a keyword, this is just a variable. By default, all the functions within the class. So this is the class, right? So this is the class scope, complete this section. So when I write, how do I know that this function belongs to this class? Because there is an indentation. We spoke of indentation yesterday, right? So how do I know that these instructions belongs to this particular function? Because we have one more level of indentation. So it's like chapter, subsection, and there is subsection. So that is the reason that it was complaining argument 1 is missing. It is, so you can see that it is slightly different from the functions. If you write a function with 2 arguments, so in class, self or the first argument, it goes as this object itself. So this is more like, if you have heard about this pointer in C++, even in Java, so it's like object itself. So how do we confirm that here? Let me show you with an example or print. This is just a way to validate ID of M. So yesterday we learned something about ID. ID is nothing but identity of that particular object. That means it's just a number that is allocated, which is tied to a memory location. It's like address of a certain variable in other languages. It's like a pointer. It gives us the, just for now, just think that it gives us the memory location or the address. So let me also try to print ID of self. This is just a variable. You can name it anything like self. This you can do it as Y as well. So this is not a keyword. Just remember that. And let me try to print in such a way that we can differentiate between these 2 prints. You can see that these numbers are different. For example, the starting of the execution started from, starting of this program execution started from 7. So compiler or interpreter looks at this class and marks it that, okay, I have a class. And then when we initialize this particular M, we use this class. Class is like a blueprint. So that is the definition of any class. Okay. So blueprint means there are only two things that is happening inside this. So there are attributes and there are functions. So one of the function is initialization. You can, that is an inbuilt function. That means it's by default given by Python. In fact, you can say something like write text is a function, and you can put some text here, and then you can also print that text here. And I'll show you how it gets invoked. So now, so it's like this pointer. So I'm passing that into this, and you can see we'll get one more error. And now we are not getting anything because Python is an interpreter. So it doesn't, until it starts executing this particular function, it doesn't know the syntax or it doesn't know what it is. So let me just try to invoke write text, okay, with text, because I'm passing some text into that. Okay. So let us see if there are any errors and try to decode why that error has come so that we don't forget. So you can see that marker dot write text takes one position argument, but two are given. So this is one of the confusions that uh, while debugging the code, it's you see that, okay, I have written a function which has only one argument, and I'm trying to pass one argument which is correct, but why is it showing two were given, right? So that is because we have one hidden element for every function which is inside this particular class has one hidden element which is the first argument. So when you send text like this, so this doesn't get translated to text. In fact, this actually gets translated to the second argument, because this text is nothing but the first argument, which is the class itself. Whether you name it as self or something else, that's a different matter. But the first argument is always the class itself. So yeah, the object itself. So this is the object that we are trying to create. So let me run it. You can see that I have written an interface, which is nothing but a function inside the class. And this is something which I have initialized. So why do we need initialization? For example, if I want to simulate a factory of markers, I would say what type of marker do I want? So I will pass all those attributes through this particular function. I would say color, I would say make, which is the material, and then I can say size, whatever. So I can initialize that, and then I can act on those attributes. So write text in, I can also say, okay, you want to write text, but using which color? You can do it like this. So this is how we think in terms of objects while programming. Okay. So that's the this is actually a very simple concept, unnecessarily made complicated to make us think that this is a higher level concept, but it is not. We are just decoding our own thought process. That's all. Okay. So how do you know that? Okay, this is a what uh, type is this? Okay, let me just try to use type, and then let us try to decode what type have we created. I think I changed a lot of things here. Let me remove all of this, revert it. Okay. Let me clear so that we have clear vision here. Okay, now we know that it is this particular thing is nothing but this address ID. Okay, and this type M, you can see that it says something like class and double underscore main. We will learn about this, but you can also see that this is what we defined. Okay. So if you remember, when we did type of integer in our previous this one, so we saw something like this, right? Python x is equal to 3. If you do type of x, you see that this is of class int. You see that this is of class main dot marker, which means that now we have learned to create objects using Python. So you can define your own data type. Now this is our data type, like just like lists, tuple and all these things. So it is also implemented using this, exactly this, and then it has a little bit complicated code, but that's it. But the idea is the same. You write a class and you write attributes and you write functions where you can act on top of that attribute, which are nothing but interfaces. So that's it. We'll learn more about this, but this is like introduction to object-oriented programming. So we are out of time already. Okay, any questions here? Yeah, you can try this and then.
Not related to this, but I had a question regarding what we
Sure.
did, what we covered in the previous this
Sure.
thing, Digant.
Yeah.
In a list, if you have to access a particular the
Element.
input within that, yes.
Oh.
So if we let's say if I call my list as my list and my list then 0, right?
Hmm.
It will print the first element,
Yes.
right?
Yes.
But if you use the same thing inside a for loop, it always goes to the second element. Why is that? I was trying to.
Inside a for loop, okay. Say, I just copy
Yeah,
this.
it's my
Let me write a for loop and say m in my list, okay, and print m. So in fact, when you're iterating, you are this is not the index that you get. This is the actual element you get. This interpretation mode. M itself is an element, like idea of M. So you're iterating through the object itself. You're not iterating through the like in C++, right? We initialize iterator I is equal to 0 and then do.
yeah.
But here there is no I at all. So I is inbuilt to this already. So the reason that we do I is equal to 0 in C++ is because the array that I have initialized, those are not objects. Those are integers or inbuilt numbers or characters like that. So all of them should be same. When you're initializing array, you should be saying that this is an array of integers. So when you do I++, you are actually jumping that many characters from that particular memory to the next set of memory. But here in Python, that logic is already built into this particular for loop. So for loop is not just a simple for statement in Python. It has intelligence to look into any data type, and it knows that, okay, this is the list of objects, object 1, 2, and so on.
Okay.
And it knows when to jump. And when you iterate, when you do this is not the iterator, but it is the object itself.
It is actually pointing to the first object rather than the
correct.
index starting with 0. Okay, got it.
Correct.
Thank you.
Yeah. And there is also sometimes you might also want to play with iterators, like in the sense that indexes. So there is inbuilt function called as enumerate. So if you enumerate this, it's like you write a list of names in the Excel sheet, and you create a new column to the left where you can number like 1, 2, 3, 4, like that. So it does that. So enumeration, let me try to print this. It will do something, and then let us try to understand that. So when you enumerate, now you look at this particular M, it is no more just these values. It also has something more to it. So, and when we try to enumerate any data type, which is an iterable, that means we should be able to iterate through. For example, X is not an iterable, it is just one element. In X is equal to 0, like there is an integer, it is not an iterable. So iterable already has function, how to get the next element. So when you enumerate, it enumerates those objects like 1, 2, 3, 4, and 5. So now, in fact, you can extract this. There are two ways to do it. Either now we are printing M, which is actually enumerated values, the index and the element itself. So either you can access like print, because now it is a tuple. You can recognize the tuple, right? Because tuple has this braces, and you can print like this separately. So that is how you access. You have just separated. So there is also something called as unpacking. We'll look at it later. But the thing is, unpacking is you can also say I, M. So when you say I, M, you can easily modify this into I and M. So this I is that number that we have assigned. It gives us the same output. So it's like that. So when you enumerate, it becomes like a column of two elements. One column has the numbering, another column has the elements themselves. And then you can access them in a for loop, either like this or using the square braces. So that is how it internally you can use the enumerated values if you want those indexes. But most of the times we won't require indexes. The reason that we define I in C is because there is no way to iterate using other than indexes. So, but in Python, it already knows. For loop is an intelligent for loop. It knows how to access these elements.
Thank you.
Okay, great. Okay, that's it for today. Thank you for staying long. Yeah, have a great day.
Thank you. Thanks, Digant.
Yeah, if you have any
Digant-
questions, please feel to send in text. Yeah, don't hesitate.
Digant, let me know your free time today so that
Sorry, yeah. We can look at it now.
now.
Or you don't, if you don't have laptop, that's fine. Yeah, just ping me if I'm free.
Okay, sure.
Yeah, just ping me after breakfast or anything.
Okay, sure. Thank you.
Okay. Yeah, guys, have a great day. Yeah.